Welcome to a whirlwind presentation on the many faces of AI, from what AI is, through its history and general applications, into the specifics of generative AI and what the near future might hold. I haven't gone too crazy, so probably will hold. There are many broad brushstrokes here, as I've said, just to give you a feel of things. The main takeaway, though, and maybe you don't have to listen to the rest of this presentation after this, the main takeaway is that AI is no longer science fiction. It's here and now. We know this. And particularly, generative AI is changing how we create and work. And artificial intelligence is simply software doing work we once left to human brains. Spotting a familiar face, understanding a sentence, or planning the next chess move. Amazingly, GenAI is pretty bad at chess. Most systems pick up those skills through machine learning. Instead of hard coding every rule, we feed the program thousands of labeled examples so that it can find the patterns for itself. Progress really exploded when researchers stacked many layers into what we call deep learning networks, unlocking big jumps in speech recognition, computer vision, chat. That's all happened over the past decade. The newest twist, of course, is generative AI. These models don't just recognize patterns, they predict what should come next, and in so doing, create fresh text, images, or code. Think of them as an ultra-powerful autocomplete engine. I think that's too basic an explanation because they are so much more complex than that, but it's a very simple context to put it in. Guessing what the next word is, the next pixel, the musical note, until the response is complete. Even so, today's models remain quite specialized. They sound fluent, but they're still predicting the next token. They're not truly understanding. So confident mistakes creep in. And we see that in the media, and we need to understand that because actually key to all of this is responsible use. So the takeaway, generative AI is a remarkable drafting tool for words, pictures, and software. Yet we're still some distance from genuine, broad, general intelligence. Now, you'll hear the big boys, Mr. Altman, Dario, Elon, whoever you like to picture, telling us that we're very close to some superintelligence. To be honest, I don't care. The point is that we've got these tools now. Students are using them, researchers are using them, the general public is using them, and we need to understand them, and we need to be aware of them, and we need to support people in using them in the right way as we go forward. Just getting on my high horse early. AI milestones. It's crazy to look back at the journey that AI has been on. 70 years ago, over 70 years ago, in 1950, Alan Turing introduced a thought experiment, the Turing test, asking if machines' behavior could be indistinguishable from a human's, a question that has since framed AI goals. A few years later, in 1956, a group of researchers at Dartmouth coined the term artificial intelligence, officially kicking off AI as a research field. The 1960s saw the creation of some pioneering programs, for instance, Eliza, a simple chatbot that fooled some people into thinking they were talking to a real therapist, and Shaky, a robot that could move and make decisions about its environment. Look up both these things if just to laugh at how far we've gone and how old the footage looks. However, progress was slower than early optimism predicted. During the 70s and the 1980s, there were periods called AI winters, when funding and interest dried up because AI had failed to meet the inflated expectations. Despite that, certain AI applications like expert systems, software that uses rules to mimic experts, were adopted in industries. Fast forward to 1997, and AI made headlines when IBM's Deep Blue chess computer defeated world champion Garry Kasparov. It was a symbolic win, showcasing computing power and algorithms. The 21st century, especially the 2010s, brought machine learning and deep learning to the forefront once more. A pivotal moment was in 2012. A deep neural network called AlexNet showed dramatic improvement in image recognition, leading to an explosion of interest in deep learning. You can almost see that as the birthing of where we are now. By 2016, AI's prowess was on display again when AlphaGo beat a Go master, an achievement many thought was many years away. Famously, in beating that master, it created a move called Move 37 that's become significant because it was a move that humans had not done. And it was widely disbelieved that this had occurred. It was a flag saying these models do more than just react to the data we give it. They can branch out from that. In 2020, OpenAI's ChatGPT-3 demonstrated remarkable ability to generate text like a human, given only a prompt. And again, if you look at the text from those kind of outputs now, it looks remarkably basic. But look, perhaps the most game-changing milestone for the public as of now was the release of ChatGPT in late 2022, which suddenly made conversational AI accessible to hundreds of millions. This last event marks the beginning of our deep dive into GenAI today. AI isn't just a theory. It is all around us. If you look in healthcare, for example, AI systems assist doctors by analyzing medical images like X-rays or MRIs. They can spot anomalies like tumors with impressive accuracy. AI also speeds up drug discovery. Google have been doing some amazing research in this area. They can predict how molecules might behave, and they can personalize treatment plans by crunching patient data. In finance, AI has been employed to detect fraud by spotting unusual transaction patterns. We all know about that from the strange messages we sometimes get from our banks. And in stock trading, algorithms automatically execute trades in split seconds based on market signals, making it almost impossible for small-scale traders to ever win. Transportation has been revolutionized by AI too. Think of self-driving cars, the Waymo car, again by Google. You can look it up and what it's doing in San Francisco. Talked about a lot less than Tesla, but has got a lot further than Tesla. They use AI to interpret camera and sensor data and relay that against Google Maps, and AI optimizes the approach that's taken. Now, there are other ones too. I'm not going to go into those, but the takeaway is AI has become a multi-tool, improving efficiency and outcomes in countless domains. GenAI is all about making something new from scratch. Give it a prompt, draw a cat playing a guitar, or explain quantum physics in a limerick, and it produces a fresh image or a paragraph that never existed before. As I've said before, under the hood, it's really a giant prediction engine. After training on a massive collection of text, pictures, sound, the model has learned the patterns that link one word, one token, one character to the next. When you type your request, it keeps on guessing the next part. Guessing doesn't feel... The problem I find with so much discussion on the subject is the words do not fit the meaning. The complexity is so much more than we understand. So sometimes I feel like I'm simplifying it down and then it becomes meaningless. That's always going through my head where I'm saying this, but I'm going to just try and stick to what I'm talking about. The breakthrough that powers today's text tools is the transformer architecture, the T in GPT. It was introduced in 2017. For images and audio, related technologies such as generative adversarial networks and newer diffusion models do the same trick in picture form. That's how systems like ChatGPT drafts essays, DALL-E, in the past that's gone away now, and Midjourney can paint artwork, and GitHub Copilot writes code from a few words of description. So in short, Generative AI predicts its way to original-looking output on demand. It feels creative and is already shaking up writing, design, music, programming, and numerous other areas. Yet remember, it's still pattern matching statistics, not human understanding. In simple terms, AI can now remember and process vastly more information than it could even in 2022. Timelines are condensing. Speed of change is condensing. This is what makes this area so difficult, so enticing sometimes to be involved in, but so difficult to comprehend and so difficult to train people on. With all these rapid advancements that you can see in this GenAI timeline here, generative AI, as of mid-2025, is a fast-moving field. Every few months brings a new model, or an upgrade, or an update. Nearly always poorly explained by the creators, because they're just speeding ahead, constantly speeding ahead. The focus now is not just on the raw power, but also on how to make these models more reliable, less prone to mistakes or hallucinations, and integrated more deeply into the tools we use. The inflection point. We've reached a real turning point in AI. I think that's safe to say. Early programs, like I've mentioned, ELIZA, simply mimicked conversation. But milestones such as Deep Blue in chess and AlphaGo in Go show machines moving from an imitation to genuine mastery with a narrow domain. Next came generative models that we've talked about. Systems that could produce fresh text, images, and audio, bringing a taste of human-style creativity into everyday tools. More recently, we've seen the rise of reasoning models. Reasoning in inverted commas. It's not reasoning like a human, but it's pausing. Large language models that can follow instructions, break down problems, and stitch ideas together rather than parrot text. Then you layer on top of this is the emerging area of AI agents. These are models given the autonomy to plan, to call tools that can help them, and cooperate with other agents to finish multi-step tasks without human steering. Early studies suggest the length and complexity of tasks these systems can handle is doubling in months. Months, not years. Put together, this journey tells us we're no longer just upgrading software utilities. We're beginning to build systems that can reason, act, and adapt at scale, nudging us closer to AI that potentially can show initiative, though we're not there yet. When you hear people talk about models as of June 2025, these are the models that people are talking about. The naming conventions are atrocious. It's almost impossible to understand which is the best model from any of the main people because they give them terrible naming conventions that make no sense. Perfect example of that is OpenAI. Now, you'd expect the best model from OpenAI is the one with the highest number next to it, the latest iteration. So you would think the best model for an OpenAI is ChatGPT 4.5. Well, in effect, ChatGPT 4.5 is a base model. It's a model that other models have been built on. So what's really the best model? Is a reasoning model that's been based off the best base model. So presently, the best OpenAI model is ChatGPT 03. Makes absolutely no sense, but next time you're in the model, make sure you click on 03 to see the best there is at this moment in time. Anthropic is a bit better with theirs. You get numbers. So we're up to Claude 4. There's then naming conventions within that. So there's more than one model that's Claude 4. There's Sonnet 4 and there's Opus 4. Opus 4 is the more powerful model. It's also the one that will use up your tokens the quickest. And then you will be very annoyed that you can no longer use the model for a certain time till that's been updated. Easier. Google Gemini, again, their the number convention's right. The highest is the best presently, 2.5. But within that, they separate out various types of model. So you have things like Flash and Pro. Pro is the best one. Flash is the lighter model that works quicker, is not so good at reasoning. And then, of course, you've got your open models. Meta have released Llama 4 recently. That comes in a number of flavors depending on how many parameters the model's running on. Lower numbers means it's basically not as powerful. But to be honest, Llama 4 is not a great model. Stay away from that. It does not work as well as the others. There are some other open source models I won't go into here, but we've all heard about, including ones from China. Be wary of ever signing up to an app that connects you directly to those models. You will be, in effect, sharing your data with China. Right, GenAI for deep research. Imagine you have a complex research question that you want a broad, structured answer to. Traditionally, you might spend days doing literature searches, reading review articles, and compiling notes to get a handle on that question. With an app like O3 Deep Research, you can hand that question over to AI and let it scout out information autonomously. The AI will go out and perform multiple steps on its own. It'll search the web. It will identify relevant papers and data, and it will filter for quality sources. It tries to distinguish between reputable studies and publications from less credible ones. It will then draft a structured report determined by the explanation and clarity of the prompt you've given it. Can it look at everything? No, can't go behind paywalls. Can't look where web crawlers are not allowed. But it can look at the whole domain of the open internet. It's a good first step. Not the full answer by any means, but a good first step. In that report, it will give you all the sections you need. It will give you key findings and even citations to sources. We used to hear about hallucinating regarding citations. If you do one deep research report and look at it now, you will find live links to every citation. You will be able to click on those and directly check to see if they're real or not. I shouldn't say guarantee, I would suggest the vast majority are real. The bigger issue you will have, and you should be checking, is to make sure the understanding that has been translated from that website makes sense within the report. Does not cut out your need for critical analysis skills, but it can get you closer to resources and citations and understanding quicker. In other words, O3 behaves like a diligent junior researcher doing a first-pass study for you. The AI is proactively gathering and sifting evidence. The output isn't just a quick answer, not by any means. It's a structured output, more organized and comprehensive, like something you'd expect a human researcher's report to provide. The structured inquiry approach yields far richer information than a single chat response. You effectively have an assistant working in parallel to you instead of you manually executing every search and summary. You delegate that to the AI, and then you focus your findings. It changes your workflow. We move from operating tools step by step to supervising the AI's research process. As with all of these things, just remember this. This is the worst deep research will ever be. It won't stay like this. The issues I'm talking about, already in the last 3 months from when they first made it available, it has improved markedly. Citations have increased. It's worked better with citations. It's easier to use, and it is more inventive in the creation of its output. Whatever you think is wrong now, hold in your mind that it will change over time. Do not get lulled into a false sense of security that because it doesn't work now, that will always be the case. Zooming out, the big trend behind tools like O3 is what we call agentic workflows. In other words, using autonomous research agents instead of AI being a passive tool that only responds when we poke it. We now have AI systems and agents that can take initiative make decisions, and perform multi-step tasks on our own. For instance, if you gave a research-orientated goal, it might decide, first I should search for this information on X. Next, I will summarize those top findings, then I'll compare the results, and finally I'll draft a report of the conclusions. It breaks the problem into those steps, it executes them one by one without any human intervention at any step. This opens the door to 24/7 assistance. I'm realizing I'm running out of time, so I'm going to speed up. However, with great power comes great responsibility, said Spider-Man's uncle. Just because the AI can operate autonomously doesn't mean we step away. Our role evolves into oversight. We curate, we validate. The AI might do 10 searches and present a summary, but we need to double check that summary, ensure the sources are truly credible and that the conclusions make sense. There's also the issue of trust. An agent might go down the wrong path completely or misinterpret something without us noticing if we're hands off. And particularly in areas we're not that expert in. So a critical part of the agentic workflow is setting them up with the right objectives and the constraints and then carefully reviewing what they produce. The next 12 months, let's put our future goggles on very quickly. The trajectory of improvements in GenAI is not slowing down. If anything, it's speeding up. The hardware, the techniques used to train these models are all improving. One statistic, historically, AI computing power was doubling every 1.5 to 2 years. But now it's doubling in a matter of months. That suggests by mid-2026, the state-of-the-art models will be 2 to 3 times more capable than we have now. 2 to 3 times more capable than we have now. We are going to see ChatGPT 5 in the next couple of months. Sam keeps changing the date, but we're looking at August presently. And all the other vendors will be releasing new models before the end of the year. They will be better at understanding context, staying factual, more grounded. In fact, Google Gemini actually has a grounding feature within it these days, and they will be better at following human instruction. There's also an effort to make these models more efficient. Different parts of the models are collapsing in on each other to work together. Adoption will continue to skyrocket. By now, many of you have at least tried ChatGPT or similar. A year from now, using AI might feel as common as using the internet, smartphones. It will be embedded. Microsoft's bringing AI co-pilots into many tools. We see it in the Windows environment in Office. Google is integrating it in their workspaces. Adobe has created it in their Creative Suite. So whether you're a student, a teacher, an engineer, a marketer, doctor, you will see AI in your workplace. Some research indicates that within a couple of years, the majority of companies will be using GenAI, at least in one department. I think it will be more than that. Oh God, I'm not going to go through all of this. I had way too much to say here. In summary, 2023, we were about the world waking up to GenAI's potential. 2025 to 2026 will be about normalization and expansion. AI will become a ubiquitous assistant in our lives. For educators, students, workers, and researchers, the key will be to leverage these tools to enhance what we do, using AI to handle the tedious or complex tasks while we stand back and focus on critical thinking, creativity, the human touch, overseeing, orchestration, judgment, empathy, care. The next year will be an exciting ride as we learn how best to integrate the AI into our society. I've covered a whirlwind of information and I've run out of time. So here's my final key takeaway. It doesn't replace the need for human insight, ethics, and creativity. Instead, if we use it right, it can amplify them. If we approach GenAI with curiosity and caution in equal measure, we can unlock its benefits while mitigating risks. I'm optimistic that by us all working together, educators, students, policymakers, industry, we can shape an AI-powered future that is beneficial to all. That is what I drive to.